This lab architecture is your safe playground for enterprise PKI. We'll spin up Azure VMs for Active Directory, an enterprise CA, and test clients, all inside an isolated network. It's realistic enough for real-world scenarios, but controlled, repeatable, and cost-efficient. You've already covered the theory, why PKI exists, and how certificates, chains, and revocation work. You also identified the Azure services and tools we'll use. Now we'll turn those pieces into a concrete VM lab architecture that we'll reuse for both Active Directory and PKI deployment. This lab gives you a realistic, but completely isolated mini enterprise to work in. You'll have a domain controller, a certification authority, and typical certificate consumers like a web server and a client machine. That lets you practice end-to-end tasks, issuing certificates, enrolling clients, validating trust, and testing revocation. Most importantly, you can break things, troubleshoot, and repeat as much as you like without any risk to a real production environment. In this lab, each virtual machine plays a specific role in a typical Microsoft enterprise environment. The domain controller is our identity and DNS backbone, keeping users, groups, and name resolution consistent. The enterprise CA issues and manages certificates, anchored to that same directory. The member web server consumes those certificates to provide HTTPS secured services. And the Windows client behaves like an end-user device, testing enrollment, trust, and real-world certificate usage. Think of the domain controller as the backbone of this entire PKI lab. It hosts the Active Directory domain your CA will integrate with, handles authentication, and stores all the objects the CA will reference. It also runs DNS so clients can find the CA, and it lets servers and workstations join the domain. Finally, group policy from this DC will drive certificate auto-enrollment, so its health must be solid before you deploy ADCS. The Enterprise CA is your central certificate factory inside the domain. Because it's joined to Active Directory, it can publish its configuration and policies directly into AD, so domain members automatically know where to enroll. It doesn't issue one-off custom certificates. It uses certificate templates to enforce consistent settings. From there, users, computers, and services can request, renew, or auto-enroll for certificates, and future labs will use it for CRL and AIA publishing. The member web server is where your certificates become real. It's a domain-joined Windows server, typically running IIS, that requests a service certificate from the lab CA, installs it, and binds it to an HTTPS site. Picture an internal HR portal. Users browse to it, IIS presents the ADCS certificate, and their browsers validate it automatically. This is the environment where you'll practice securing internal websites end-to-end. The Windows client is where you see how your PKI actually behaves for real users. First, it joins the lab domain and receives group policy, including trusted root SAs and auto-enrollment settings. Next, you perform user and computer certificate enrollment. Then you validate trust, opening sites in the browser, inspecting the certificate store, and walking the chain. Finally, you simulate failures like revocation to practice troubleshooting. In a simple lab, one enterprise CA issues all certificates. That's easy to manage, but it hides how real organizations protect their root of trust. By adding an offline root CA VM, you can show a two-tier hierarchy. The root only signs the issuing CA, then is powered down, modeling stronger security. The issuing CA handles day-to-day enrollment, while the root stays protected, setting you up for deeper PKI design discussions later. For this lab, imagine one clean bubble in Azure that everything lives in. That bubble is a dedicated virtual network used only for the PKI environment. All lab virtual machines share a single, simple subnet. They talk privately to each other, but not to your production or personal workloads. You might expose only a controlled entry point, like an RDP gateway, and keep all certificate-related traffic strictly inside this lab network. A clean private IP plan keeps your lab predictable and easy to rebuild. Give the domain controller a static address and treat it as your primary DNS server. Do the same for other infrastructure roles, like the certificate authority and web server, using a simple pattern of addresses. Leave client VMs on DHCP unless they truly need static settings. Most important, write everything down. VM names, roles, IPs, and DNS settings, so you can recreate or troubleshoot the lab anytime. DNS is the foundation of your lab. Start by giving the domain controller a static private IP. Then set the Azure Virtual Network DNS to that IP, so every VM automatically uses it. Avoid public DNS servers, they can't resolve your internal AD names. Renew leases or reboot VMs, then test with commands like nslookup dc01 corpor, contoso.local. Only when name resolution is reliable should you join servers to the domain or install ADCS. Remote desktop is powerful, but an open 3389 port is basically an invitation to constant attacks. At minimum, restrict RDP by source IP, so only trusted locations can connect, and use it only temporarily. A stronger option is Azure Bastion, which keeps RDP off the public internet entirely and uses the browser instead. For maximum protection, layer just-in-time access, so RDP opens only when needed for specific users and auto-closes afterward. Treat your lab as a long-running project, not a quick test. Choose modest VM sizes that still meet your needs. Enable auto shutdown so machines don't run overnight. Limit public IPs and open ports. And regularly delete unused disks, snapshots, and resource groups to avoid surprise bills. You've now built a realistic lab: domain controller, web server, client, and optional offline root CA, all on a planned private network with working DNS. You've locked down RDP, tuned VM sizes, and controlled costs. Next, we'll stand up Active Directory, then design and deploy an enterprise-ready PKI.